It does. It does. Oh, no, but Steve, over to you.
Thanks very much. So, for those new to, have we got any newbies? I think there might be one or two newbies here today. Um, my name's Steve Boda. I'm a droid builder and an alcoholic. No, I'm not. Um, I am a droid builder though. Been doing this for quite a few years. I come from an RC background. I My past sort of history is in RC. I was a professional drone pilot for a number of years, with a number of film and TV credits. But when it came to controlling a droid, my first choice obviously was RC, because that's what I'm familiar with. But I wanted to try and use a system that was a bit more ergonomic and a bit more user friendly, shall we say. And also at the time, RC was backed up by using remote relay systems in order to produce sounds. Obviously, things like writing scripts for servos and things to open was also very uncommon at that point as well, particularly. So I happened across the Padawan 360 system on the Astromech groups and started reading up on it. And I thought, actually, yeah, maybe that could work for me. I had an old Xbox 360. In fact, I've still got it just over there. So I had a spare controller, and I thought, oh, okay, let's have a look at this. Quickly fell in love with it. I think it's a brilliant system, incredibly ergonomic. Of course, the whole point of the Xbox 360 controller is that it's built to fit in your hands and it's built for you to use it without looking at what your hands are doing. RC, sometimes, once you've got a good familiarity with it, you can kind of do the same sort of thing. But these things are purpose built from the ground up to be ergonomic and also very, very compact. So I fell into working with this a bit, and I did not write the sketch. I will absolutely please push you towards a guy called Dan Kraus, who wrote the sketch originally. It is a port of some other code called Padawan, called Shadow, but this one was called Padawan 360 because obviously it's based on the Xbox 360 infrastructure. Just to kind of tell you a little bit about, again, we're not going to go into massive depth on this. I'm going to try and kind of give you this for people who aren't as familiar as perhaps some of our newer people. So Padawan 360 uses as its core a little sort of, you could possibly call it a computer. It's not really a computer. It's a microprocessor called a Arduino. And there's different ways you can do it, different flavors of Arduino that you can use. The most common one that's in use these days is the Arduino Mega and the particular variant of it called an ADK board. Now, the important thing about that is that the ADK board has built-in USB onto the actual board itself. Prior to that, or if you're using a different kind of board like an Arduino Uno, you have to have something called a shield. And what a shield does is it sort of piggybacks on top of the chip, and that's sort of, it acts as an expansion board, if you like, and that's what gives you USB. That used to be great. When I built my first system, in fact, the one that's still in my droid in the other room now, that was built on an Uno with a shield, worked out the box, absolutely no problem at all. Unfortunately, the Chinese suppliers of these piggyback boards, in their infinite wisdom, chose to build them with an incorrect chip on board within recent years. Also, there are a number of little solder pads, little pins that you have to kind of jump across. And none of this was particularly well documented at the time. The first host shield I bought was made by a company called Keys, Keyes, and that literally worked out of the box. It was perfect, just worked first time. The boards from the likes of AliExpress and therefore that kind of cascades down, so Amazon, et cetera, other sellers, all for the most part come with an incorrect chip soldered on. Now it's quite handy that they've actually silk printed on the board. On one of there's two sort of main chips on the top of them. One of them is labeled up on the silk printing. It says AHC on the actual board itself. But if you look with a pair of glasses or a little magnifying glass, The actual chip on board is not the AHC variety. It's a 74HC125 or something like that. It should be a 74AHC125. It's all to do with voltage control, and it took the combined might of various forums quite some time to figure this out. I think I bought 13 different boards at one point of different manufacturers or different suppliers in China and elsewhere to just basically try and find one that worked. So it kind of ends up that you may, if you have an existing one of these piggyback boards or shields, that you may have to remove the HC chip, buy some AHC chips off AliExpress, and they're really, really cheap. You can buy 10 for a couple of dollars, and basically replace that. I've done a video on my YouTube channel showing you how that works, how to do it. It's actually not as scary as you might think. As long as you've got a soldering iron, ideally some solder paste, it just makes your life an awful lot easier doing that particular job. So that is one. That is the older way of doing it. As I say, these days, if anyone comes to me and says, how do I put a Padawan board together? The first thing I will say is just go ahead and buy an ADK board. It gets rid of all of those issues for you. It's an Arduino Mega with the USB already on it. There's no solder jump pads to do. There's no chips to check, nothing like that at all. They just work. And they're still relatively inexpensive. I just bought two more yesterday, and I think they were £30, which is going to be what, $40-ish, something like that. So they're not horrible, and it just literally makes your life 100 times easier. So that's the main sort of part of the computing power, if you like, of the Padawan 360 system. Now, Arduino is an amazingly versatile platform and is actually used in an awful lot of different things. So Shadow uses it as well. Things like Kyber, they don't use Arduino as such. They use something else called an ESP32, which is a very similar sort of processing platform as well. But that's obviously tied into RC and not really some part of this particular conversation. What I will do though is just sort of quickly say that Padawan 360 may not be the best fit for everyone, may not be the best fit for you. If anything to do with Arduino really scares the pants off you, then maybe avoid it. But it really isn't that difficult. If you're going on to potentially work on film and TV sets, Padawan 360 probably isn't for you. You want to be looking at traditional RC. There's no one right fit for, there is no one right fit for everyone. It just so happens that this particular system is very, very popular. And because of the sort of support this community has given me, I wanted to give something back. So I started producing a series of videos on this particular system, and hopefully those have been of help to some people out there. So the fact that it's built on this Arduino platform gives us the flexibility to do other things with it. And it also gives us the flexibility to change things as more and more things come along. Now, something obviously that is in the offing is Michael's version 4, for example, of the of his droid, particularly with regards to the drive. So in the past, obviously 3D printed drives were based on DC motors, scavenger drives, DDR2s, whichever kind of drive it is. You may have a 3D printed droid, you may have a metal and wood one like mine, but they all traditionally were based on DC, typically scooter motors. So you'll hear the likes of the Sabertooth 2x32 being mentioned all the time, which is a very, very robust and solid motor driver. It does sort of tank steering as part of its kind of makeup. That's what it's there. It's a dual channel board. But more and more people are looking towards brushless technologies. Brushless is incredibly torquey, it's incredibly compact, and as Michael's design for his Mark IV looks like doing, it can literally 3D print the entire drive system minus the actual hub motor itself. Cost-wise, well, they're actually reasonably comparable to a full to a full DC setup. So by the time you've got your scooter motors, by the time you've done your foot drives and all the gears and the herringbone, the herring gears and all that sort of stuff. And by the time you've got your Sabertooth 2x32s and all that sort of stuff, it's not a million miles off going down the brushless route. And because it's Arduino based and all we're doing with the Xbox 360 system is passing commands back and forth, If there's ways of supporting the motor drivers for the brushless motors, then there's nothing to stop us actually being able to drive complete brushless setup through Padawan 360. And in fact, at DB UK last weekend, that was demonstrated. One of the members, I don't know if Steve Sloan is on the chat tonight, but Steve Sloan had a test demo board set up, which I rode around on, sat on this board and sort of drove around with an Xbox 360 controller quite happily. Very, very torquey, very configurable. So what I'm trying to sort of get across is that you are not tied necessarily to just one thing and that's it. There is obviously sketches out there that do one thing and that's absolutely phenomenal. That's kind of where we all started. But also things like, for example, the default um, the default sort of bill of sale, no bill of you know what I mean, the things you have to purchase. Um, the soundboard on them was something called the SparkFun MP3 trigger. Now those are horrendously expensive for what they are, especially by today's standards, where MP3 players, cost a matter of pennies now compared to what they used to. So I tweaked the sketch slightly and I found a different kind of soundboard called a DY player. It's not the DF player mini that some of you might be thinking I'm talking about, but a DY player. It's got a 3.5mm jack already on board. It's got obviously a micro SD card slot, and it's even got an amplifier on board as well. Runs off 5 volts, runs off serial, so you don't have to sort of do anything special with putting resistors in line and things like that you do have to on the DF players. And all it is a few changes to the lines, some of the lines in the actual the main Arduino sketch. So just kind of going back to that, a sketch, for those who don't know, a sketch is the program, if you like. That's how we write code for the Arduinos, and it uses something called an IDE, which is a programming window, and that's where your sketch lives. Your sketch lives within this IDE, and we use that IDE to also upload any files. Now, I know a couple of people also have messaged me about maybe having some confusion about what is a file, what's a sketch, what's a library, how do I get libraries uploaded? Do I have to upload them first, etc., etc. So I'll just kind of clear up a couple of those things. Again, apologies if this is old hat to a lot of you, but hopefully there's some newbies that might get something out of it. So when we are trying to upload a sketch, okay, let's kind of go back a step. Let's say, first of all, you've downloaded a sketch either off Dan's GitHub page or my GitHub page that suits the sort of build you're putting together. Well, once you've got that onto your computer, typically you would open it up within the Arduino IDE or the programming window. And normally the first thing you do is try to do something called compile. Now, what a compile does is it checks that code is okay, and so it won't just blindly push it onto your Arduino and then it fail for whatever reason. So your computer will go through a number of checks. When we are writing the code for these things, we can include something called a library. Now, what a library does is it's kind of like a compact pre-built snippet of code that does a lot of the functionality for us, and it allows us then to actually interact with the code in a much more simplistic way. So we don't have to write out all of the commands. We can just basically tell it to do whatever it is we want it to do. And it will go off into this library and actually say, right, what do I actually need to tell whatever's on the other end of that, what to do? So a library is something that you will be required to install within your IDE program or within your programming window. But there's nothing else you need to do with it after there. You don't need to separately upload it. So if you had the Padawan 360 sketch open, you'll see it says include, there'll be a little hash sign that'll say include, and it will say something like include sabertooth.h or include siren.h or the Spark for an MP3. It may say MP3 trigger.h, and these are basically calls to these libraries that you will have had to install. So you can always tell if you don't have the libraries installed, because when you try to compile it, your computer will complain no such file or library found, or words to that effect. So if you've hit compile and you've got one of these errors, then chances are you're missing, and it will tell you in a little red sort of section at the bottom of the Arduino screen which one you're missing. So it's a relatively simple task to go and find it and install it. I'm not going to go into how to install libraries as part of this chat. There's loads of information about that online. Just go to YouTube and say how to install a library on Arduino. It's very, very simple. So when it comes time to actually then push this sketch onto your Arduino board itself, you're obviously going to have the Arduino plugged into your computer. Make sure that it's selected on the port. Now, there's a handful of gotchas here and there. One that I know has caught people out in the past, especially if we're talking about using the Mega ADK board, which is, again, going back, that's the one with the USB socket already on it, is that it is possible to actually treat that board as if it's just a bog standard vanilla Mega board. So you can actually upload the sketch if you had the wrong board selected in that case. So if you had the Mega selected, the sketch will upload to it, but it will not take advantage of the features of the ADK board. So it won't find the USB port. So what you must do in that particular case is you must select the board type as Mega ADK. In fact, let me, just whilst I'm talking, I go and grab.
Is that because it loads drivers, Steve, or is that because it's a completely different way of uploading the code? Or,
I
sorry,
don't think it's.
it uploads libraries rather than drivers.
I think so. I'm not 100%.
Okay.
I'll be absolutely honest. So let me just upload. Sorry, I'm just pulling up a sketch on my computer. Now, I don't actually have a Mega ADK board to hand. I did have 3 spares, but I had a couple of unfortunate incidents last week at the DB UK event and ended up going through all of my boards. So I can't actually demo uploading this for you right at the moment, but I will, once this comes up, I'll do a share screen. He says, oh, share.
Does that mean I owe you one of the new patches?
No, it wasn't actually me, but yes, it was someone I was helping. Right. Can you guys see my shared screen?
Yes.
Okay, so can you yeah. Doobie-doobie-doo. Yes, I know I'm screen sharing. I'm trying to drag. There we go. Okay. So you can see this hopefully on my screen. Can you see all this that I'm sort of highlighting at the moment? Yeah.
Yeah.
Fantastic. Okay. So for the uninitiated, this is the Padawan 360 sketch. Now this one is a slightly tweaked example that is on my GitHub page. And this particular one uses the DY, the cheap audio player. And it also supports a board called the Maestro, which we'll talk about as well shortly as well. So basically what you get within a sketch, if I just kind of come down here, there's a load of integers, which are basically setting up things like the 3 options for your drive speed in these 3 locations here. And it says, yeah, what's your default drive speed at startup? A lot of it. So the way that this coding works, again, apologies for those who are familiar with this sort of stuff, but the way code is written is it's actually quite understandable. It's not complete jargon. So long as someone's already written it, you can actually understand it. So another setting down here, for example, this is one I asked Dan to include because I thought it was quite important. The original Padawan 360 sketch was what I call right-hand drive or right stick drive. So basically you drive the droid around using the right thumbstick and you'd change the dome direction with the left thumbstick. Now, to me, that was as a gamer, as a gamer on sort of Xbox or PlayStation, that was kind of counterintuitive because if you're playing a first-person shooter game, anyone who's sort of played Call of Duty or whatever, you move your character around with the left stick and you look where you're going with the right stick, which to me meant I would want to drive the droid with the left stick and he can look where he's going with the right stick, if that makes sense. So we got a little variable put in here, or a little Boolean called, is it left stick drive? In other words, is it left-hand drive? So if that's set to false, then the actual droid is right-hand drive. And you can see I've actually named this particular file right stick drive. And this was at the request of someone who's got limited mobility in their left hand. So they wanted to be able to drive the droid with their right hand. Dome speed, this is this variable here. So basically we can tell how fast the dome is going to spin. Now you might think, well, why do we even need to set that? Well, the reason why you might want to do that is because of your voltage that your particular system is running at. If you're running your system at 12 volts, then that dome speed is going to be half of what it would potentially be if you're running at 24 volts for your main system. Padawan doesn't care. Padawan really doesn't care what voltage you're running at. All this is doing is kind of running a very basic computer program. And I'm going to sort of say that in air quotes a little bit. So, you've got options for changing things like your maximum dome speed. There's things for what's called ramping, which is basically how fast it accelerates. You can even set things like the dead zone range. So this is if your Xbox controller has got slightly dodgy sticks where it kind of tends to drift off a little bit. Well, you can kind of build in a level of dead area around the center of that stick. So you can obviously play with all that sort of stuff to your heart's content. A couple of things here about communicating to the saber-tooth and the dome. In other words, so if you're familiar with the saber-tooth and the siren speed controllers, then you probably realize that you have to change a couple of the dip switches on them, and that's all to do with being able to communicate with those. You can set what volume you want it to be at startup, how loud it's going to be. And then again, the beauty of a system like Padawan 360 is you can even do things like control the volume remotely on the controller. You just can't do that easily on a traditional RC transmitter. And I say traditional as opposed to something more advanced like Kyber. Anyway, we're getting now to the meat and bones of what I was just talking about, and that's these bits down here, okay, where it's where it says #include. Sorry, my the mouse pad trackpad on my laptop's a bit dodgy. So you can see a number of these statements here that say #include and then something within the triangular brackets. Okay, so #include DY player audio Arduino.h. That's a library. That's a call to a library. Okay, so what that will do is your machine, when you try to compile this, will go away and say, have I got that software or that library installed already on the computer? The Arduino doesn't care about it particularly, but your laptop does, because it's your laptop that's going to bundle all of this code together and then push it all up to your actual Arduino. Then the Arduino is going to look after it. So you only have one upload to do. Okay, you do not have to go and individually install all of these. Also, just a couple of other sort of things. Again, apologies. I know this is probably telling a lot of people how to suck eggs, but again, for the newbies, you only can push code to an Arduino. You can't pull it back off. So if someone said to you, oh, I've got this great program running on my Arduino, here's my Arduino, plug it into your machine, you can't pull that software off it. There is no way. It's a kind of a one direction thing. The only way you could do that is if that person shared their code with you, and then obviously you're free to upload it wherever you need to go. So yeah, so we've got these things called libraries. So you can see there's one for one for something called software serial. We'll talk about that maybe in a moment. The Sabertooth, which is also used by the Siren 10, that uses the same library for that. You can see that on this, the one for the MP3 trigger. Now that's the spark for an MP3 trigger. You can see I've got two slashes in front of that. If you see two slashes in an Arduino sketch, your Arduino code will ignore that line. So basically what we describe that as is commenting out the line. So this particular line is commented out. So this particular sketch does not use the spark front MP3 trigger. Instead, you can see the very next line says include DY player Arduino.h. So I'm using the DY player board instead. Then we have some other bits and pieces. Wire is a very common one. This is like a communications protocol for Arduino. And then Xbox Rec V. This is the main code that tells the Arduino to recognize an Xbox receiver. And there's lots of interesting things we can get into with that as well. I'm not going to delve too much in that right at the moment. The next include you can see on mine is include Maestro.h. Okay, so the Pololu Maestro is a servo control board at its core. It can actually do a lot more than that. And maybe if we get time, Michael, how long do you want me to sort of talk for?
You can go for an hour, Steve. To be honest, if we've got questions and discussion afterwards,
Yeah. Okay.
there's no
I'll.
question. Just carry on, really. To be honest, I mean,
Okay.
it's
Cool.
more of a
Okay.
chat.
Is the level kind of okay for everyone?
Yeah.
Yes.
Yeah.
Yeah. Cool. Okay. Cool. Um. So yeah. So we've talked about, the fact that you can control sounds with the DY player in this case, or an MP3 trigger if you've got a spot for an MP3 trigger. But controlling like panels opening and all that sort of stuff, there's a number of ways to do it. Pololu Maestro is probably one of the de facto standards mostly because the software that supports that is incredibly versatile and incredibly easy to use in comparison to doing it the traditional way. And I'll sort of tell you about that in a moment. So I am going to just see if I can switch over to this screen here. Are you seeing a slideshow now?
Yeah.
Cool. Okay.
Yeah.
So talking about options for controlling servos. The actual main Padawan 360 sketch runs what I would describe as critical code. You absolutely want to do as little as you can to make changes into that code, because constantly that code is what is controlling your droid. So if you accidentally introduce something in there that slows that operation down, there's a very good chance that you might lose control of your droid. It might go off and do something you're not expecting. So controlling servos directly from the Padawan Arduino board itself is a bad idea, as K2SO would say. So a couple of ways you can do it. You can use another Arduino board and talk to that one over something called I2C or I2C, which is like a language, a protocol for talking between different Arduinos, but it kind of does limit you a little bit. You can use something called a PCA 9685 board, which is a sort of a servo expansion board. But again, you need an Arduino to be talking to that board in order to then talk to the servos. So I'm going to talk about something called Pololu Maestro, which is it's just like food of the gods when it comes to doing this sort of stuff. So the Pololu Maestro, it is a dedicated servo control board, but as I say, it's capable of doing more than just controlling servos. You can also use it to turn relays on and off and things like that as well. They come in a variety of sizes. You can, from anything from 6 to like 24 different channels or servos or whatever you want to connect. The software though is absolutely its raison d'etre. The Maestro Control Center software, which we'll have a look at in a minute, is just absolutely fantastic. You can do things like speed ramping natively within that code. So if you want to, you can have typically, if you say to a servo, go from this position to this position, it will do it as fast as it possibly can. But with the Maestro system, you can literally tell it to take its time and slowly open that door or raise up an arm or whatever it is you're doing. The support for Arduino and for Raspberry Pi, which is another kind of mini computer, is phenomenal, very, very well supported. And it's even capable of running different servo voltages. So, for example, with the B2EMO, you might be running your servos at a much higher voltage because of the extra requirements of the current draw or the power requirements. So the Maestro board can just easily cope with different voltages. They're also daisy chainable, so you can actually add more than one. As far as hardware is required, well, yes, you need an Arduino Mega, ideally with Padawan installed and working. Then you need your Maestro board itself, some servos, pretty obviously, a computer to help program them, some jumper wires. You'll be required to put some sort of data wires and some power wires in. I these days just use DuPont crimp and make my own connectors all the time, because then you know for a fact that those wires are good wires. The kind you buy in a big sort of ribbon strip, the actual wire within them is incredibly thin and can be quite brittle as well. So I would recommend, if you don't already own one, just go to AliExpress and buy yourself a DuPont crimp connector kit, and you'll never look back. You'll need some way, obviously, of powering them. Do not power your Maestro board through your Arduino. Okay, keep the power all nicely separated out. So the board itself requires two sets of power, if you like. It uses power to provide logic to the board, and then obviously servo power. But helpfully, if you look in the bottom right-hand corner, if you can, I don't know if you can see my mouse moving, but in the bottom right-hand corner of the picture of the board, there's an orange sort of block. Now, when you buy a Maestro board, when you sort of take one out of the packet, there'll be a little blue jumper just sitting on the end pin on it, all on its lonesome. If you use that little jumper thing to jump these two pins here, it means that whatever voltage you drive down the rails here, there's plus and minus, will also provide power to the board itself from a data perspective. So it's very, very straightforward to run. Otherwise, as well as power, we need to sort of be able to talk to it. So we need some logic or some data connectivity. So you need a common ground. And oftentimes when you're putting a board together, all your grounds typically would be tied together anyway. We won't ask Rick about sort of common grounds. But that's a way of making sure that everything has got a common ground. And then you have an RX pin, which is that one there. And optionally, you can also connect a TX. So basically, your board can also send signals out. So not something we particularly use in this, but you could have your Maestro board telling something else that it has completed a particular sequence, for example. So power, as I said, you can tie that across on the mini Maestro boards, which is the 6-channel ones. It doesn't come with that little blue jumper because the pins are actually further apart. So you can just use a DuPont sort of jumper wire, or you could even just solder a wire across if you wanted to as well. I would recommend, as I say, running your own power. That just avoids something called a brownout, and brown is never a good color to be involved in anything, especially electronics. It can be the same voltage if you want, but absolutely don't power it off the Arduino. You can power it from the Sabertooth, but sort of do that at your own risk. I would recommend you had sort of, a discrete, what's called a buck regulator. I'm sure some of you heard that phrase before.
So questions actually, just in chat. The first one is on the Maestro. So how do you daisy chain them?
Okay. All right. So if you can see down here, there's a pin marked TX in, daisy chain input.
Okay.
It's actually, honestly, it's something I've not done. I've never done it. But you do have a TX in, so you'd probably be TX outing from one of them and TX inning into the next one. I don't have a good answer for you on that one. It's a little bit outside the scope of what I intended to do on this, but it definitely, when I've got a requirement to do it, I will make a video of it and post it up.
Basically, you set one to a discrete identifier, like set 1 to 1 and 1 to 2, and then you run them on the same serial bus into one, and then the daisy chain out. So it's pretty easy.
Yeah.
How would you set the identifier?
The identifier is the control software, the Pololu control software.
Yeah. Cool. There was 3 questions. The second one was creating sequences. How do you create pauses?
We're going to come on to that.
Yeah. Okay. Cool. And the third one, is it possible to add some logic so that servo B won't activate unless servo A is at a specific position?
So I'm not as experienced as all you guys on this. I'm one of the newbies, but I actually just bought the 12-channel Maestros, and the software that Steve was talking about is very intuitive. As Mark just put in the chat too, you're allowed to create sequence, which is very, very easy to do.
Yeah, we're going to talk all about that in a minute.
Trust me, if I can do it, I know you guys can.
Trust me, I'm an engineer. Okay, is there any other questions that anyone wants answered before I carry on? I'm quite happy to take a little pause if anyone wants any other questions. Okay, in that case, we will rattle on. So let me see if I can get back to there. So yeah, the Maestro Control Center software, as we were just talking about, in order to get it up and running, you may need to install some drivers. You definitely will need to install the software, but the software is free. You just go to the Pololu website, search for Maestro, or even just in Google, say Pololu Maestro Control Center, and you'll be able to download the software. Very, very simple to use. All you need to do, first of all, is connect your Maestro board to your computer using a mini USB cable. And then it should pop up where it says connected to. On mine, you can see that I'd obviously unplugged it when I took the screenshot, but where it says not connected, that will connect to your actual board. So all you have to do, if not, is hit connect and it will just connect for you. Very, very easy to use. It's a case of enabling the servos. You can see there's a little box here for enabling servos. Excuse me, you literally drag the sliders around and your servos will start moving so long as you've got power going to your board and to your servos. So that enables you to set limits or set sort of, if you've got something that's overstressing a door that's trying to open, then you can say, right, okay, I know that I can't go any higher than a value of 2000, just picking a nice round number on that. And what you can do, and we'll talk about it in a minute, is you can actually then go into the channel settings, which is the third tab along there, and set 2000 as the upper limit for that particular servo. So what it means for you is when you're starting to create your sequence, so we're kind of getting ahead of ourselves a tiny bit, but when you start to create your sequence, you don't have to worry about overdriving the servo because you've already set in the channel settings what your maximum is for that particular channel. Does that make sense? Hopefully, I think it hopefully makes sense.
Although, can I add a little warning?
Please, yeah.
The first time you power a servo and you plug it in and that channel hasn't been enabled, that servo is going to jump to the middle of its range. So that may be too far. So plug the servo in.
Yeah, don't have control horns on first.
Right, because and the other thing is if you start a sequence with all your different animation speeds, if that servo, the first time you turn it on, it's going to move at full speed. So turn the servo on before you move it in your sequences. Otherwise, it's going to move at full speed and jerk.
Absolutely. Yep. I was gonna mention that anyway, but yeah, thanks for jumping in. No, not at all. No, please. I'm glad that you did. I'm glad that you did. So there's kind of like, a number of baby steps you're going to be taking. So the first thing I would suggest you do is obviously not have it all connected with all the hinges and all of the control rods and everything first, because you're kind of asking for trouble. Just pop the horns off all the servos, make sure they all kind of work and they're turning in the right direction, for example. So you may find that something's trying to pull a door closed even more than opening it. So you can set all these maximum and minimum values up in the channel settings tab. Then we're going to start doing something called creating frames, which is what we use to build what we call a sequence. And then finally, we copy those sequences to a script, and then and only then do we actually push the script onto the Maestro board itself. Everything that you will be doing up until that point is effectively your computer via the Maestro telling the servos what to do. So the Maestro itself doesn't remember those commands. We do that by creating the script and then applying the change to that setting. So I was planning on doing a demo, but I don't know if I've got the leads to do it here. Let me have a look. Give me one sec. Sorry, I wasn't not really as well thought out as I planned to be on this. Okay, so if you can see it, that's a Maestro board.
Oh, yeah. Disappearing in the background. But...
Yeah, I know. Yeah, sorry. Let me get some light going here as well. One sec. I should have. Oh, look at that. I just found the right sort of cable as well. Fantastic. So yes, we will be able to do a quick no holds barred real world live demo. So I am just plugging this via a mini USB into my laptop. You can see I've got a couple of little flashing lights on there. So at the moment, I'm not going to be actually plugging servos and things into. No, I'm not going to plug servos because I would also need to provide power to this, and I just don't have that to hand at the moment. But it means I can show you the control center software itself. So on my laptop, I'm just going to type in Maestro. And momentarily. Okay, can you guys see the Maestro Control Center software in my screen?
Yeah.
Cool. Okay. So couple of things to note. First of all, I didn't do anything to tell it to connect to this. It was obviously already plugged into my computer, and then I fired up the software. So it knows that it's connected to that particular serial number of board, and it even knows how many channels are on this board. So this is a 12 channel. If it was a 24 channel, it would have shown you 24 channels down there. Couple of things to note. First of all, as far as it's concerned, the first servo is known as number 0. Okay, so it goes from 0 to 11. So just bear that in mind. It's a little easy to get confused, but I'm going to show you a way of also mitigating that. So under channel settings, it also allows you to name each servo. So, okay, this one is known as number 0, but I might want to call this door. Okay. The next one I might want to call arm. The next one, oops, arm, can't spell arm right. The next one I'm going to call gripper. And for the moment, we're just going to stick with those 3. Okay. Now, down here, apply settings. You're required to apply settings for pretty much any change that you make to your software. So now that I've applied that setting, if I go back over to my status, you can see now I've got 3 named servos. So I have to worry less about what number each servo was, because I've got a handy dandy name for each one.
Can I just reiterate for everybody there, Steve, that if you don't apply settings and you go to another tab, you lose your settings.
Absolutely.
You got to keep saving.
Yep. Pretty much any change you make, you have to apply that as you apply the settings for that change to take effect. I did mention also that this isn't just a servo control board. It can do other things as well. So let's say I had a smoke machine that was running off a relay in my droid. Then I could create one here called smoke relay, and I can class that as an output. And you'll see now that I don't have things like the hertz or the frequency that the servo runs at, because this is now no longer a servo channel. So again, apply settings, go back to status, and you can see now that I've got an output for smoke relay. So if I was to turn that on, I basically got I can now give that still values, but it means I can turn a relay on and off. Which is, and I actually do exactly this in my dome. So one of my channels, which does run a little miniature smoke machine, is literally an output on a relay. So, okay, we've now got.
Sorry, Steve. The output still outputs a servo signal. So it still sends a hertz between 1,000 to 2,000.
I actually don't know, because I just basically either go to one extreme of the value of the other, and it just works. I think it's just switching 5 volts up and down, or whatever.
Is it high or low then? Yeah. Okay.
I think it's someone might want to jump in and correct me on that, but that's what I've used it for, and it has worked. It's worked absolutely fine.
That's cool.
Yeah, I was a little confused about that myself, actually, because obviously this is all grayed out now, and yet.
Hello? Yeah, it doesn't allow you to set an upper and a lower, does it? It's kind of
back of the car.
You move it, but you can't.
Oh, sounds like someone's in the back of a car. Hello, Doug. Sounds like Doug anyway. Is it Doug?
Well, I listened to 40 minutes of it. I think I've done my bit. They started fucking doing river dance. I was like, no, that's it. I'm out.
Yeah, river dance isn't my favorite either. It's not just me that's hearing this, is it?
A little bit.
Yeah, no, we all hear Doug.
I was like, I was stood at the burger van queue, and I was like, "That's Susie. I better record that. I better record one bit."
Oh, I was enjoying that.
Oh, that was it. I was waiting for him to say something bad about me. Oh well.
I have no idea what Doug was talking about then, but
no, all I heard was burger van and back of the queue. Anyway,
he's doing burger vans and river dance, which gives you an insight into Doug's life.
Yeah. Someone please message Doug saying we really enjoyed your talk about the river dance. Okay, right. Let's kind of get back to the plot a little bit. So we've got one of our boards, we've got a number of servos, and we now want to start doing things with them. As I say, this channel settings and especially the minimum and maximum values is your friend. Okay, you really, really, really want to spend a little bit of time setting these minimum and maximum values to avoid, moving an arm too far or opening a door too far or closing it too far and, potentially damaging your servos. But again, the beauty of these boards is you can even do things like turning these on and off, turning your servos on and off, literally cutting power to them to avoid things like buzzing. So,
and you can also control LEDs, can't you, with it, Steve? So it's not just
as an output or PWM. Yep, absolutely. So let's say that, okay, what we want to do is we want to build an animation that opens a door, raises an arm, kind of gives a few clacks of a gripper, makes sure that's closed, drops the arm, closes the door, and then sort of shuts the power down. So we're going to create something called a sequence. Okay, so if I come to the sequence tab over here, you can see at the moment that there is nothing in the sequence tab. So I can say I want to create a new sequence. I can give it a name if I want. So I'll call it if you want. Okay, so now I have an empty sequence. There are no frames. Okay, so the first kind of part of this is we're going to build frames, which if you think about, if you understand what stop frame animation is, sort of like the old plasticine models and all that sort of stuff, we're kind of doing something a bit like that. Okay, we're building a load of keyframes, if you like, if you're familiar with that term. So in the bottom left-hand corner down here, hopefully you can see it says save frame 0. So this is basically our starting operation. I'm actually just going to get rid of that smoke relay for the moment, so I don't confuse things too far. So right at the moment, I have got, let's say I've got 3 servos attached to this board. They're kind of just flapping around loose inside my droid some at the moment because I don't want to break anything. But the first thing I want to do is to turn perhaps all of those servos on. That would be the first frame. So I can literally enable them all at the moment. They're set to the midpoint, which is 1500 in programming terms. So this is using something called PWM, and I'm not going to go into the details of that particularly, but servos, if they are sent a value of 1500, that is the centering point of a servo typically. So what I'm going to do is go to the bottom left-hand corner here and say save frame 0. Boink. Okay. So now I have frame 0 saved. So if I go to my sequence, you can see that I've got frame 0 saved there. Now, if I had power connected to this and I had servos connected to this, basically all of those servos would have snapped to their center point on that point. Let's say now the first thing I want to do is open the door. Very simple. I can drag that to whatever my value was for the maximum.
For accuracy in the commands, was that an oink or a boink?
That was an oink.
Okay.
It was a yoink, actually. It was a yoink. Okay.
I want to make sure I got it right.
Oh, yeah, this is important stuff. So, so the first thing we're going to do in this particular example is we're going to open the door. Okay. And as I say, you're going to set that to whatever your value was that you will have predetermined is your maximum value for opening that door without overdriving it. And then we're going to save a keyframe. We'll save frame 1. Okay. Now the next thing I want to do, let's say we're going to raise the arm up. So I'm going to drag that up to its value wherever it needs to be. I'm going to save that as a frame. Then I'm going to open the gripper, save it as a frame. I'm going to close the gripper. Now, if you want to get this back to 1500 and you're trying to sort of drag it around and you can't quite get it slap bang in the middle, no problem. All you can do is tap within the target, type in the number 1500, hit return, and it will center it for you. So now I'm going to save that as another frame. And again, let's say I want that the maximum value. So let's say 2000 in this case. Hit that, save a frame, go back to 1500. Hit that, save the frame. So you see I'm building this up stage by stage or step by step or frame by frame. Now, if I just go back to my sequence tab now, you'll see that I've got 7 frames from 0 to 6 already saved.
Steve, may I make a quick comment?
Please do.
Actually legitimate. One of the things I did with some of the sequences that you're talking about right now was I changed the input source of the gripper, so that what would happen is I'd have the sequence in the Arduino, obviously watching for the input, and then, pardon me, in the Maestro, watching for the input. It would then open the door and extend the arm and so on and so forth. But then I made it sit and wait for me to use one of the potentiometers on the controller for how large it opened and closed and under what circumstances. I found this to be extremely helpful when it was dealing with ring bearer duty, which R2
Yep.
has done more than once, so that it's not dependent on the timing the way that I've set it up, but in fact, it's dependent upon waiting for it to be the right time to open it. And then I twist the pot, open it so rings could be taken off. And then when triggering the closure from a different input, it would reverse those actions. But the point being that you can do layers of controls. You can even have it where it's purely a setting you've programmed for the initial opening, for positioning things, and then you can make it sit and wait for the input from a pot. So just throwing that out there, that it doesn't always have to be one movement equals, one set of plans and always entering the values and doing it a certain way. You can actually mix it up in there to give you more control.
Totally. That is one of the beauties of this. I could literally stop this particular animation here, and the droid would sit with its door open and with its arm open and its gripper at this point closed as it happens. But yeah, I mean, obviously, if you're talking about pots, I'm guessing you're talking probably more about RC as opposed to Padawan.
It was indeed. It was indeed. Which of course was what you were aiming at to begin with. But
yeah, but you could do exactly the same sort of thing using a trigger, for example, on Padawan, because you can the trigger is as a variable rather than like an on or off value. I think.
Well,
it's not something I've ever gone into in Padawan, but
no, that's fine. I just wanted to toss
the
out there not only the possibility, but also there are very inexpensive items that you can put, and I'll try to find one and put it into the chat, where it takes the output from the RC control and turns it into essentially a binary switch. Is it on or is it off? Which is what you can monitor for in the RC world to trigger a movement, whether that movement is open and wait or whether it's, close it and go away.
Mm-hmm. Yep. No, you're quite right. The focus of this particular talk, though, is on the Padawan system, so that's kind of why I'm sort of focusing on basically what we're going to come on to in a minute is how to trigger a script and all that sort of stuff. But you're absolutely right, and this is why I extol the virtues of these things. They are very, very flexible indeed. So yeah, thanks for that. Okay, so kind of getting back to what we were saying. So in this particular instance, what we did is we've opened the door. We've extended the arm or lifted the arm up. We've told the gripper to kind of open, close, or however many times we did it. The next frame I'm going to do is I'm going to bring the arm back down again. So I'm going to say, put that to its, again, arbitrary center value. Your values obviously will be completely different, but I'm going to save that frame. So the important thing is you make sure that you think about this logically, okay? So you're not going to close the door before you close the arm. You're not going to close the door at the same time as closing the arm, because obviously they will clash, okay? So you need to sort of just think logically through every step. Your system is not clever, okay? It will not realize that you've got an arm that's out before it tries to close the door. It will not care. So you do have to make sure you do these things in a logical order. So
it's one of the drawbacks of servos. There's no feedback on servos. So with this, like Steve said, if you move it to a position, the servo moves as fast as it can to that position. If in the software you move the servo to the end position and then move it back quicker than the arm can move, it'll almost look like the servo's not moving because the software doesn't know that the arm's got or the servo's got to the position that it's got to. So I think one of the things I would do is I'd grab the software and just play with it. But what you'll find very quickly is that what you've got to do is almost tune these things by sight to see where your end stop is, give it a second, and then try and pull it back just by altering the timing systems. So it'd be great if servos did have that kind of feedback and it knew where it was, but it doesn't do. So it's a brilliant piece of software. It's limited by the way that servos work in that it's only really output. You tell it where to go, and eventually it'll get there. It'll get there as fast as possible.
Another thing that I do when I'm tuning the servos is I look at my amps coming off my benchtop power supply, and if they're pulling 0.5, 0.6 amps, and I think the servo's at rest, it's not at rest. It's hitting something.
Yeah, indeed. So if you hear any buzzing, anything like that, that's obviously a bad sign. You don't want servos to be straining against anything at any particular time. And we're going to turn all our servos off once we finish with this as well in a minute. Just whilst sort of to pick up on what Michael was saying as well about servos not giving feedback. It's another great example of how something can go wrong is if you tell a servo to go to a particular position that it cannot attain. Okay, so it's a value that's either above or below its maximum values. That servo will just ignore what you told it to do. So, and you may not realize that that's what's happening whilst you're going through this process, because if you're dragging this bar from this way to this way, and let's say in your channel settings, you'd actually said that the minimum value that this could go to is 400. Let me just apply that. Then you can see now I've got a lot more. And also anytime you applied settings, it actually turns your servos off. Should have mentioned that as well. So you can see now I've actually got a lot more leeway to go to a far lower target value. Now, if your servo, taking this slightly extreme example, if I had sort of servos connected to this and they're powered up and they're in the droid and I'm sort of using this to kind of feel how much travel I want. If I kind of drag this to the left and I go all the way to the left and my servo reaches the perfect position, I might think, great, that's worked like a charm, and I save that frame. Now, it may well be when I come to play this back that servo does not move to that position. The reason for that is because when I was testing it, what I did is I dragged this down. So the value, if you look at the target value, that's changing. It's decreasing, it's decreasing, it's decreasing. The servo is reacting to this in real time as I'm dragging this bar around. So right now it's trying to achieve a value of 594. And ultimately, I may go outside of the boundaries of what that servo can recognize. So say my servo doesn't recognize anything below 500. Well, all of this part here across to the end, the servo's not recognizing, it's not doing anything. I won't have picked up on that because I just simply dragged the bar and I saw the servo move. So as far as I'm concerned, everything's right with the world. But if I was to save this frame now, what happens when this plays back is that the value will go from whatever the previous value was. Let's say it was 1500. It will go from 1500 to 400 straight away. It will not drag through as I drag that bar across because I've saved a frame just at that point. So if I tell it all of a sudden to go to a value of 400, the servo is going to go, don't care about that, I'm going to ignore it, and it will stay where it was on the last one. And that's where you can end up with a clash with a door hitting it, for example. So do be aware and careful that you do set your upper and lower limits within the channel settings correctly. Okay, so find out what your minimum value is, find out what your maximum value is, and do not stray beyond those points.
And that's why you're probably better just grab the software, grab the Maestro board and throw some servos on it. There's some servos that have hard stops, so they'll physically inside the servo, they'll have a stop position. And if you push it, like Steve says, to 400 when that stops at 600, what you'll be doing is just pushing the motor against a solid object. Eventually it'll just burn out.
Not just that though, but cleverer servos like digital servos will absolutely just ignore the value and they won't move at all. Ask me how I know.
Yes, but you have to be familiar with the combination of the servo and how it operates when you start to change those numbers. And the other constraint is if you put in, I think what Tim was saying, if you put it in a mechanism where you're closing a door, opening a door, lifting an arm, you'll then reach a physical limitation on your mechanism. So the best thing you can do is have just throw a servo on it, run the software up, and then just see where it lands and just see how just learn how it drives before you start to add the complexity of all the mechanical build on it.
Cool.
Quick question, Steve.
Shoot.
So I asked you
anything about a
DBUK.
burger van?
No, it's not. No.
Okay.
So I asked you at DBUK about zero position. So say you've got servo that's got 180 degrees, but obviously I got servo savers. But say you wanted your pie panel closed, you didn't want to use the horn as your zero position. Because you're actually going to the full, stroke of the servo.
Well, it may well, just your linkage might be a different length or something.
So say your servo is in mid position. Do you set the position on the software there as being whatever that is, and that's your home position then?
Yeah, so basically, let's say you've got a panel that's either closed or it's open, typically, okay? So your midpoint, strictly speaking, would kind of be halfway between closed and open. So and this goes right back again to what I was saying about setting your minimums and maximums. So I'd set your minimum as the closed position. I'd set your maximum as the open position within the channel settings within here. So let's say that this door at its closed position actually was a value of 1500. No, because that's the mid. Let's not choose that. Say 1100. And fully open, let's say it was actually 1750, just for the sake of argument. That then within my status window, let's call it a frame builder, just to sort of give that a more descriptive title. You can see now that I've got my minimum and maximum values only between 1100 and 1700 or 1750, whatever I set it to be. So that means that when I'm now throwing that servo around, I don't have to worry that I'm overdriving it closed or open, because I've set the potential minimum and maximum values to be whatever they're going to be. So all I have to do.
The theory on that would be that's almost say like, I know that's not relative in terms of figures, but that could be like your 10 degrees to 170 degrees of a 180 servo. Yeah.
Exactly. So I mean, servos work between 1,000 and 2,000, and 1,500 is in the middle. That's the kind of way that RC works. With RC, you can stretch out to 2,200 and 1,800, so you can lengthen it either side. But you do it, 800 to what you end up with 1,500 in the middle. But really, what you want to try and do is get. I tend to center the servo, center the mechanism, and then what I do in the software here is just gradually move it across until I get an open and a close. And then once I've got those figures, I make a note of those figures, and they become my upper and lower figures, like Steve said. At that point, then your software constrains your maximum mechanical, and otherwise you really do risk burning servos out. If you push a servo against a solid wall and it's just constantly trying to drive that, all it'll do is overheat and smoke out.
Thank you.
And make Rick very happy. He can sell another patch.
He can sell another patch.
Ship out another patch.
I have a patch.
Yeah, jump in if you got a question.
Yes, I have one question here. The target here, would it be very, very useful if they actually had a percentage here, like 50% being in the middle and but out of the min max range?
Not necessarily, because not all servos are the same. So you can get 180 degree servos, you can get 270 degree servos, you can get 360 degree servos. So I agree with you. It's not a bad idea, but the value is more traditional. This is at a programmatical level, if you like. Basically, this is like common. This is a common language.
A bit surprised that because then if you change the minimum and maximum, the range for the movement doesn't have to change, right? If you switch in switch servos or something.
But I think with the GUI, because you've got that slider bar, your slider bar will reflect any changes that you make on the upper and lower. So actually, if you wanted to go 50%, you just drop it to 50% of the slider bar. If you alter the upper and lower, it will alter proportionately. But you're right. There isn't a percentage entrance on there. The target is always the millisecond signal that's relayed to the servo.
There is some tweaking. If you go to channel settings, there's more than the min and max. There's an 8-bit range. You get the speed and acceleration, which I found only work in the in this mode. It doesn't work per patch or per channel. So
so the speed and acceleration you hard code per servo. So if you choose a servo, what speed is normally servos run at a set the fastest that they possibly can, like Steve said. You can slow it down on there to make it run really slow and really, and then acceleration gives you more of a natural move where you ramp up and ramp down to where you're getting from. But once you set it at a servo level, it's set. So if you had an arm that you wanted to move fast and then slow and then fast, you can only have it at single speed. But what the output of this produces a bunch of code. You can go into the code, and at specific times you can override the acceleration and speed, but you're getting into the coding on it then. The documentation that's with it's quite comprehensive, so you can do some very sophisticated stuff with this. But what the GUI does is it produces the first basic set of code for you then when you feel a little bit more confident and a bit more advanced to be able to go in and ramp stuff up or increase speeds, midway.
Can I add a pro tip for those who are first mucking around? When I was setting this guy up, I thought to myself, I'll be really smart and create a default position for all of my servos using Maestro. What I didn't expect, though, was the doors can close a lot quicker than the arms lowering when you put those things in place. So I actually ended up having to create sort of two actions, basically. One which lowers all arms, but make sure the doors are open first, lower all arms, and then run a second sequence, which was close all the doors.
You could definitely do that.
Then I also, with any action that, like for instance, the action you're doing here, I do with the Padawan, I click it once and it does that action, and it basically stays doing that action until I hit the same button again, and then it reverses everything and shuts the play.
Another way of doing it, which is what I was actually kind of going to explain to, again, people who are new to this stuff. As I said, we're trying to obviously avoid any clashes, so we want to make sure the arm is down before the door is closed. So in our last frame, we moved that servo to the closed position for the arm. Now, there is nothing to stop me saving another frame with that door in its closed position, and even another frame with that door in its closed position, with the arm in its closed position, without moving the door. What that does, if we look in our sequence, is it gives me 3 lots of time. So each of these frames is separated by default by 500 milliseconds or half a second. What I've just done there is I've built in a second and a half where nothing happens. Okay, so the arm came down. Now it's basically repeating: the arm is down, the arm is down, the arm is down. So it's giving us a second and a half before I'm then going to go and close the door, save that as a frame, and then I'm going to turn all the servos off, save that as a frame. So now I will have all these extra frames down here, effectively where really not a lot's happening, until such time as I think the penultimate one, I told it to close the door. Now, what you can do from this particular point here is you can play the sequence. So let's do that. I'm just going to click on the first frame. I'm actually going to tick this little box up here that says play it in a loop, so it gives me time to sort of describe what's happening. So I'm going to say play the sequence. And you can see there's a little arrow that steps through each of those frames. And remember, a frame is just like a stop frame animation, and then it flicks back to the top again. So if I go to my status, you'll see all of these starting to move. Now, obviously, we kind of turned the servos on and off as we were applying settings and things. This isn't...
Hey, Steve?
Yes, sir.
Just something I just learned. I don't know if you knew this, but you can grab the sequence tab and drag it out to the side as a separate window.
Absolutely, you can. So you can actually do that. And that's a great tip. Thank you for pointing that out. Yeah. So you can actually watch this step by stepping whilst you actually see what it's doing. And your servos would be moving if they're, if they're all attached and powered up whilst it's doing this. Okay. So at any point, obviously you can say stop sequence and it'll stop wherever it was. Okay. Let's say that one of your points in your sequence wasn't doing quite what you wanted it to do, and you actually needed the gripper was kind of not opening wide enough, or it was closing too much, and you wanted to change it. Oops, sorry. Let me cancel that. You can load any particular frame. So any of those frames that your stop frame animation, you can load it in by clicking on that, and as you can probably see, all your servos will move to that position. Now, you can say, right, actually, what I wanted to do was that wasn't quite the right position. Where I really wanted it was there. I can sort of drag it to where I want, and then I can say save over current frame. If I click that, that is now the new position for that particular frame. Excuse me one sec.
So you didn't hit apply settings
tweaks
at that point. You just went straight to the save over current frame. Is that what you do?
Correct.
Or yeah, okay, cool.
I believe so. I haven't got servos attached, so I can't really.
Yeah, I know. Yeah,
I
figure you're working blind,
what happened. So
I get it.
I don't think there's any harm in hitting apply settings. I almost hit after everything, to be honest.
Yeah. As a general rule, the first thing I do when I do anything is hit apply settings. But we're kind of getting into a little bit more advanced stuff anyway. Now, something you might have seen when I clicked by accident, one of the other questions I think was about timings of stuff and making sure that something is closed. And I showed you a bit of a kludge, a bit of a ham-fisted workaround by literally saving 3 frames worth of nothing happening. Okay, so that frame, and that frame were all doing exactly the same thing. So I built in a 1.5 seconds delay. What I could have done is if you double click on a frame, you can actually change the duration here as to how long that takes to do its action. So if you've got a door an arm that needs to come down that takes longer than 0.5 seconds, there's nothing to stop you from saying, all right, I'm going to give that 1,000 milliseconds. That duration of that particular frame is now 1,000 milliseconds or 1 second. Does that make sense? Yes, Steve. Oh, great. Okay, good. I'm glad. You can also change the order of frames. So if you got something in the wrong order, well, there's nothing to stop you from moving that frame up or down using those ones here. So the frame properties is the same as double clicking on it. You can even change the name of these frames. So this software is so powerful. You can say, close arm. So you can name each individual thing. Now, this does also become useful in the next kind of thing we're going to do. But I'm conscious that I've been talking for an awfully long time, so I want to kind of just rattle through a few more things at the end here, okay? So what we've done, don't forget, thinking right back to where we started, we've created one sequence here. I called it Grippy 1. But I want my servos to do more than one thing. So I'm going to create a new sequence. So now you can see I've got 2 there. I'm going to call this one, you name that one red and door. And I can go through all over again, create loads of frames, save them. Notice that over here on the left-hand side, this is now defaulted back to save frame 0. So that would be the first frame, and then I would do the second frame and the third frame and the fourth frame and however many frames I want. So I've now started to build a second sequence. And if I look at my drop down here, you can see I've got either my first original one or I've got the new one I've just created, Red Pandora. Now, in a similar way to Arduino, you remember right back to where we started, one of the first things I told you about was that with Arduino, you upload one sketch. You just do one hit and that's it. You can't upload bits of it, a bit of it at a time. It's a bit of a one-hit wonder. You push everything and that's it. Much the same happens with the Maestro Control Center software. What we're going to do is we're going to copy all sequences to a script. So what we're going to do now, we've created our stop frame animation. We've produced a sequence of those frames. Now what we have to do is create something called a script, and it's the script that will get pushed onto the board itself. Do you remember I mentioned back that at the moment, this board knows nothing of how to run this on its own. The computer, my laptop, has been driving all of these movements. All I've been doing is through my computer using this as an interface to talk directly to the board. The board knows nothing about how to memorize any of the stuff. So what we have to do is create something called a script. Easiest way to do that, there's a big button over here. It says copy all sequences to script. And over here, you can see now it's changed to the script tab, and there is our script. Our script, you can see, has got two little, let's call them subscripts. I don't know if that's the right phrase for it, but you can see there's one called bread pan door, and there's one down here called grippy. Okay, and it's this area that you can go in to start changing things like the ramp speed individually per servo. This is getting into far more advanced stuff than I wanted to talk about, but what I just want to show you here is this is how we have now created the script. Now, at this point, let's say, yeah, I'm perfectly happy with that. I'm going to do some tweaking later on, maybe. I can either run through the script. That's not going to be wonderful because it's going to be running all sorts of different things at the same time. Or I can apply settings. Now, when I hit apply settings, I don't know if you'll be able to see it, but if I'm going to hit apply settings now, probably happened in too fast a time, that has now written that code onto the board. So I could now unplug this board from my computer, plug it into the controller, so the receiver pins and all that sort of stuff. And now I can start to tell my Padawan sketch what buttons to use to trigger off these sequences. A gotcha with this, which I actually tested on Monday, and it seemed to be okay. Someone has said that you have to have at least 2 sequences to be able to trigger this from the Arduino. I did test this on a board I built for one of the builders, and it was fine with just 1 sequence. So that I'm slightly on the fence about. I don't know for sure whether or not that's an issue. Anyway, so we've spent quite a bit of time talking about this, and I know I'm well over our sort of allotted slot. So I'm going to try and wrap up as quick as I can. So let me come back to this slideshow. A lot of this information is already online on my YouTube channel. So if you go to Imperial Light and Magic on YouTube, there is about an hour's worth of video, pretty much telling you everything I've just told and shown you here about creating scripts, and particularly about Maestros. But within Padawan, we actually have to tell it to tell our servos to run, to tell our board to run whichever of these scripts. So obviously we said you've got to have the library in there first of all. We're going to very quickly talk about understanding a key combo, finding or existing ones or replacing one, and whether or not we're going to use hardware or software serial. So we need to make sure we've included the libraries for Pololu Maestro. If we're going to use something called software serial, which just determines which pins you use on the board, you may need to use this, have the software serial library. So as you can, I've got 2 examples down here of using either hardware serial or software serial. And it's just sort of naming conventions about how we tell our Arduino which one to use. So we have to tell it to basically start serial. And then we look at the keyboard combos or the key combos. So this particular key combo that's on the screen now, you can see it says if Xbox get button press L2, 0, which basically means has L2, which is the left trigger, been pulled. Then you'll see there's a curly bracket and it says if Xbox get button up. And you might say, hang on a minute, we just told it to to look for L2. Well, what this is doing, this is a combo. Okay, so what it's doing is it's saying, is L2 pushed? Yes. Is up pushed on the button press, which is on the D-pad thing? So in other words, if L2 and up are pressed at the same time, then I'm going to, in this particular case, maestro.restart script number 0. Okay, notice I don't have to use the naming convention of the scripts. So, I may have called that first script Grippy 1 or whatever it is. As far as from a coding perspective is concerned, that was script 0. And you can see I just kind of had a little comment in there saying L2 and up, start script 0. So I might do L2 and down, and I might use that one to start script 1. So say I can have a script that opens all the doors. I can have a script that closes all the doors. Entirely up to you. So you can have a script that opens alternative panels, and then I can have go back to script number 1, which closes all the panels, regardless of whether they were open or closed, for example. Again, we can do that with something called software serial. This is just another example using the right trigger and up. So, okay, that's that's kind of most of what I wanted to get across. But there's some really important things to just go back to and cover. We did mention right at the top that Padawan is not just about using the DC drive motors. It's not just about using the Spark and MP3 triggers. Because it's based on Arduino, it's flexible. You can tweak it to do whatever you want to do. Just be very, very careful that you don't introduce any delays into that loop of code, because that's a really bad idea. But what you can do is you can use other speed controllers such as Cytron, the Flip Sky brushless controllers for the badly marked 4 drives in development at the moment. As I say, that will be coming soon. Steve Sloan is working on that, and his work has been so far absolutely fantastic. You can even have things like there's an extra called a chat pad that clips onto a controller, gives you another myriad of options for controlling, again, Maestro scripts or whatever it might be you want to do. There's connectivity, the Astro Pixel system. I don't have a demo of that ready for you today. You can use different soundboards. So it's Arduino based. It's got lots of potential, but whatever you do, please do not delay the loop. Okay. If you're going to issue any commands, do not put delay in there, because it potentially can have catastrophic effects on the control of your droid. If anyone wants to take a screenshot of that, that's some useful resources. So Dan Krause, the original creator of the Padawan 360 sketch, libraries and all that sort of stuff are also on his GitHub page. So, excuse me, please do go and show Dan some love. None of this would exist without Dan rewriting this code. My page is github.com/imperial_L&M. So I've got various tweaked versions of the code with Maestro support, the DY player support, different libraries. So, for example, if you do wanted to use a chat pad, you require a different version of something called the USB host shield library. Also, my YouTube channel, to give myself a slight bit of self-promotion, Imperial L&M on YouTube. Lots of useful Padawan stuff on there. There is a Padawan 360 playlist as well. So that's probably quite a good place to start. Things have changed since my first videos. I've changed the way I've done my build slightly. So do make sure you have a good watch through most of my videos on there for all the latest sort of stuff. And I think that's it. So has anyone got questions? Oh God, I shouldn't have even said that. I know there's going to be questions. So please fire away with questions.
I popped all the links in the chat, Steve. So.
Oh, fabulous. Thank you.
Yeah. And Chris, the recording has been made. So yeah, I'll share that afterwards.
Cracking, cheers.
Make sure it's
Steve, first of all, thanks ever so much for going through all this evening. It's been really helpful. Thank you. Is there any documentation on how to trigger the scripts using the chat pad?
Documentation, probably not. Sketches coming, if they're not. There are sketches available. I don't think I've got any on my page.
I've just done it, so I might dump what I've done up on line with Michael's permission, if anyone wants it.
Yeah, definitely. I think the chat pad, it really gives us an extended bunch of buttons to press. So where Steve talked about combos with the chat pad, assuming the library supports it from a Bluetooth perspective, it's just a matter of changing that a little bit.
Yeah, this is something I've literally just been working on. So in fact, so the library to support chat pad is also on my GitHub page there.
Cracking.
Yeah, just to point out on that one, it is dated, that library. Sorry, maybe not yours, Steve. I'm just the one that I grabbed seems to have been dated, and there's a few things that you've sort of got to work around in order to try and get some things working the way you expect them to work. And some things just don't work, like, for instance, those like shift keys that are on the chat pad that are down here, the green one and the orange one, because I thought, I'm going to add not just 20 buttons, I'm going to add 60 buttons.
60, yeah.
No, you don't. Those aren't actually implemented in the library.
But I think you probably would be able to then use the L1 or the actual trigger buttons on the controller.
I have been
and a button on the
trying that,
trackpad.
but there's a delay.
Okay.
When you hold your L2, for instance, and then hit one of them, it just takes a tiny split second to react.
Okay.
So there's a little bit of a delay, and it's probably due to the fact that there's that one little plug that's actually plugging into the chat pad.
Yeah, indeed. Jim, I think you got a question.
Yeah, just first, thanks for doing this. I love just the walkthrough. I didn't miss the beginning of it, so if you already answered this, apologies. I was just kind of curious. It came up the other day when we were talking about like safety features and like remote cutoffs and things like that. And somebody had the question of like, how does Padawan work with like losing access to the controller? And so I'm curious if you've already mentioned what happens with the Maestro specifically in this case, and like how to recover from like if it gets stuck in a loop or something.
Yep. So that's an excellent question. It's kind of a bit of a two-part question. So let's say you're driving your droid around and a little kid runs into you, bashes the controller out your hand, goes onto the ground, batteries come out. Okay. If we look at the loop of the, hopefully everyone can still see my screen. If we go to the loop, which is like the main part, if you like, the guts of what Padawan and Arduino is all about, the first thing it does, literally the first thing it does, is it says, are we connected to the controller? Okay. If it's not connected, it turns the drive off, it turns any turn motions off, and it turns the dome motor off as well. Okay. So it fails safe always. We have tested this numerous times, and also in the UK, we have a process for clearing our droids for insurance purposes. And one of those tests is that your droid fails safe. So they will literally turn your transmitter off or take the batteries out, regardless if it's radio control, Padawan, Shadow, whatever. Every single time anyone has built a Padawan system, it has sailed through that test, no issues at all. Okay. Yeah. To your question about what would it do if the Maestro had been triggered, that's a good question. What I would do, and in fact what I do on my own personal droid, is I have separate sequences built for separate animations or separate movements, if you like. So as I kind of touched on, I've got a sequence that if I do a particular key combo, I know it will close all panels regardless of what state they're currently in. So if it kind of got stuck, or like I say, it somehow locked up in a particular loop, then I know that this particular key combo will just close everything back down again. Likewise, if I've got something where maybe I've got I want to get everything open, I'll have a sequence that just opens everything. Otherwise, I build sequences that kind of open the pie panels in alternate sort of things. I've got one that will just open one a bit and then kind of give it a little bit of a wiggle as a wave and then close it again. But it's a good question, actually. I'm not 100% sure what it would do in the event of a control loss. I don't think actually it would be too bothered, because as I say, the main thing about this loop is it says, are we connected? And if we're not connected, then turn the drives off. So it doesn't seem to actually be too bothered about the actual Maestro board. So I suspect that if it was halfway through a long and complicated sequence, it would probably just carry that sequence on.
The Maestro runs independently of the Arduino. So once you kick the Maestro off, it'll run through its sequence, and the Arduino can go and do whatever it wants to do thereafter. The interesting one is if the Sabertooth, the motor controllers, if the Arduino failed, but the Sabertooth was on full speed, what it would do without the Arduino signal, because the Arduino signal's in serial. And I don't know the answer to that because I've never been asked.
Touch wood, that's not happened.
Yeah.
Well, actually, do you know what? Funny enough, I can answer that because it did happen on Sunday at DUK. And as I say, that's why I'm actually out of ADK boards at the moment. We had a situation where an ADK board, so the actual Arduino itself, did blow up literally whilst the droid was driving. Droid stopped.
Steve, about that closes everything. What happens if you have sequences that didn't work? Like you've got an arm out, for example. What happened if you hit that loop to close everything? Wouldn't that interfere with the fact that the arm is out?
Yeah. So if I noticed that there was an arm out and a door open, and for some reason it locked up, I would not run the code that closes everything. I would basically just rerun the script that did whatever the motion was.
Yeah. What I did with Chopper when I did Chopper, because there's the arms that come out, there's a flex that comes out, the doors that open, and I was very conscious that if you turn the power off halfway through, the arms could be any position, the doors could be any position. So the startup sequence of Chopper on mine it assumes that everything's in a complete chaotic mode. So the first thing it does is open the doors fully to make sure the doors are open fully. Then what it does is it gets the arms to a position where they're okay. Then it pulls the arms in. Then it closes the doors. That's my power up sequence. So depending on the animation you're looking at, you need to think that through. But your power up sequence assumes that there's nothing there, and what it should do is restore everything to being a position that you can start your animations from, if that makes sense.
That's great. If you don't mind if I chime in, just because I really feel like ties a lot together with kind of the question I had with the Maestro, and I haven't learned how to program the Maestro yet. That's kind of why I was looking at this, but I can totally see myself ending up in like an infinite loop where like it's just trying to destroy itself. And so like I think this is like a really great case for introducing like that remote cutoff where you can shut down the entire droid. So if something goes wrong, let's say you've got a servo that's trying to close and a kid's there and you lose connection, like I'm just catastrophizing because I do. And so like Michael just said, I didn't even think about that. But then if you have that remote cutoff, you can shut power down to everything and back on, and then that's going to open all the servos back into a safer spot.
Yeah.
So yeah, just
Yeah, so
I'll
you
drop a
can have a
link into
remote
the
relay.
chat for kind of what I've been using that's been effective. And
yeah, for sure. You can use a remote relay to kill power to your droid, no problem at all. And as Michael said, all you do then is you have a default power up sequence. Again, we're sort of getting onto fairly advanced stuff that's a little bit beyond the scope of what I wanted to cover on this particular chat. This is it's potentially a huge subject. We'd already sort of well over the sort of how much I was wanting to talk for, and literally was kind of scratching the surface of some of this.
Sorry about that. One very
not at all.
way to handle the question is I have a completely separate cutoff that is its own appliance. It hangs like a keychain off the RC unit. It doesn't matter what unit you're using, but it cuts off the main power feed. And it is the last step. It's a single button push. I've in fact only used it once, and that was to test it. But it'll cut off the power entirely so that you have that fail-safe that no matter what's happening with your droid, you can just completely cut it off. Just cut the power off. And I'll throw
remote relay.
Not that it's the only solution, but I'll throw in the chat the link to that as well. And while I've got the floor, Steve, congratulations, big time, to Milo.
Thank you.
Success of the work he's doing. And also be sure to tell him from us, congratulations on surviving 18 years with you as his dad.
That's much appreciated. Thank you very much. I will pass that on when he's back from the pub.
Well, as it should be.
Thanks. So that's from the heart. That is really appreciated. Thank you very much. Everyone has been so nice. It's been wonderful. But anyway,
it comes from the heart, and especially watching them spend other people's money. So,
there's that as well.
Effectively.
Brilliant.
Any other questions? Happy to.
Can I add one more pro tip and share my screen on my Padawan 360 setup?
Let me stop my share then.
So, a pro tip. When I was getting confused doing this for the first time, I'm just going to
let me just remove Spotlight off myself.
I started getting lost with stuff, and So what I ended up doing in my actual Padawan 360 code, all of my Maestro things are explained as what they actually do and what they're called. And then I go into actually calling them. So it's just a little tip that comments are your friend. And yeah, once you start doing a lot of these animations, it can get, and the same thing with your MP3s. If you've got a load of MP3s and your triggers down in mine, at the very start of mine, I actually named what each one of them was in my, so I can actually look up what the hell was that number again. I used it last time I was out and about. I couldn't remember what it was, and then so I just looked up my code, which I keep on GitHub on my phone, and then looked it up. Anyway, that's all I wanted to say.
Your code is just little notes to your future self. That's all it is. Because you think you understand it today, and I'd not just put it on code. I'd also put it on cabling, wiring, labeling, documentation. We're all terrible at documentation, but if you want to put yourself little breadcrumbs for your future self, so they can understand what your current self is thinking, it's always a great idea.
Absolutely.
Now I can't share what's going on.
Whilst you're trying to figure that out, is there any other questions?
Yeah, I had a quick one on servo deactivation. So for horizontal servo movement, like the doors, I tend to activate them, open them, and deactivate them, save power, they're not running. Vertical ones like CPU arm, I leave on so it can muscle it up. I didn't see any little checkboxes for deactivation and activation. How is that handled in the Maestro?
Yep, you just activated it or not activate it. There was a tick box.
Oh, there's a tick box.
Yeah, in each frame, if you untick the tick box, it's not powered.
Oh, that's fantastic!
It's powered, so it's that simple.
I missed that. Thank you so much for the clarification.
Yeah, that's it.
Great talk.
Thanks, David. Cheers. And good to meet you last week as well.
Good.
Yeah. He did his YouTube voice in the kitchen party after. It was quite something to see up close.
just I could listen to it all day long. That was brilliant. Right, I'm going to hit stop recording, I think, after that session. Thank you, Steve. That was brilliant.